Reflection on spherical mirrors. Reflection happens when light rays bounce off on a surface. In the diagram, the ray of light approaching the mirror is known as the incident ray. The ray of light that leaves the mirror is known as the reflected ray. Reflection also happens on spherical mirrors. Concave mirror is also called converging mirror because the reflected rays converge or meet at a specific point. Convex mirror is also called diverging mirror because the reflected rays diverge or separate after hitting the surface. Let's recall that the concave mirror is a curved mirror whose reflecting surface is curved inward. It is also called converging mirror. Convex mirror is a curved mirror whose reflecting surface is bulging outward. It is also called diverging mirror. Here are the important terms we often use in describing the reflection on spherical mirrors. Object. It is anything that faces the spherical mirror. It is represented with an arrow during ray diagramming. Image. It is the reflection of the object on the spherical mirror. We also use an arrow to represent an image during ray diagramming. Ray diagramming is the graphical method of locating the image. It uses the four principal rays: PF ray, FP ray, CC ray, and V ray. How is the image located? The point where the four reflected rays meet or intersect is the point where the image is drawn. It is alright to use only 2 or 3 of the 4 principal rays in the diagram, as long as there are 2 reflected rays that intersect or meet. Then you can draw and locate the image. Take note, if the 2 intersecting rays is an incident ray and a reflected ray, it is not the correct point of image location. Always check if the intersecting rays are 2 reflected rays. Then it is the correct location of the image. If there is no point of intersection between at least 2 reflected rays, we can extend the reflected rays at the back of the mirror to see if they intersect virtually. If extended reflected rays meet behind the mirror, the image is virtual. If the extended reflected rays do not meet or intersect, then no image is formed. Location. Where is the image located? The possible answers are behind the mirror, and or in front of the mirror. We can also use the points where they lie or formed on the diagram. For example, the location of the image in this diagram is beyond C, or beyond the center of curvature, while in this example, the location of the image is at C, or at the center of curvature. The image can also be located between the center of curvature and the focus, or between C and F. Orientation. The possible answers are upright and inverted. If 2 reflected rays meet below the principal axis, the image is inverted or upside down. If 2 reflected rays meet above the principal axis, the image is upright or erect. Size. What is the height of the image? We compare the size or the height of the image to the size of the object. It can be the same, which means the height of the image is the same with the object. It can be reduced or diminished, which means the size of the image is smaller than the size of the object. it can be enlarged or magnified, which means the size of the image is larger than the size of the object. Type of image is based on the location of the image. We look at the location of the image. Is it behind the mirror? Then it is virtual. Is the image in front of the mirror? Then the type of the image is real.